Hey, how's it going? This is worksheet 2.6 for the right side of your interactive notebook. So we're going to start by finding whether or not a given ordered pair is a solution to an inequality. Remember, this is your x in an ordered pair and this is your y. So we simply substitute 0 in for x and negative 1 in for y in the original equation. Copy everything very carefully. So we simplify this. Honestly, folks, you can just take this and plug this into your... Anything inappropriate there? I don't think so. Nothing personal, I should say, of students. So you can plug, what I was trying to say is you can honestly just plug this into your calculator and you would get positive 3, I think. Otherwise, you can like chip away at it. I would do a little chop slash. So sure enough, you get 3 is less than or equal to 2. And so here's where you have to take your time and make sure that that is true or not. Answer that question quickly. This is false. Like the inequality, the Pac-Man should be eating the other way, so this is a false statement. So then that means that the point 0, 1 or 0, negative 1 is not a solution. If we got it in a true statement, then it would, yes, would be a solution. So this is false. All right, let's try this other coordinate pair. So we're supposed to try these two coordinate pairs into this inequality. So now we'll do 2 times 3 minus 3, and then the y is 2. So 2 goes in place of y is substituted in, is less than or equal to 2. And as we simplify this, we get 6 minus 6, which is 0. So your calculator should say on this left side, you get 0. So then we ask, is 0 less than or equal to 2? That is true. So that means that 3, 2, that coordinate pair that I was checking, is a solution. Awesome. Let's keep trying that with the other ones. So now we have a new equation. If you look at number 2, we've got a new equation. See it on your paper because you can't see it. Oh, now you can see it here. And we're going to substitute, first of all, 2, 0 in. So 2 goes in for x, 0 goes in for y. Let's do this. So 4, oh, you know what's tricky here? They tried to trick you. The y is right there. So it's going to be 4 times 0. It's not actually in standard form. It's sort of the values are switched. And then x goes over there. Minus 2 times 2 is less than 5. So we get 0 minus 4, which is negative 4. Is negative 4 less than 5? That is true, yes. So yes, 2, 0 is a solution. Okay, now it looks like we're supposed to try negative 3 comma 1. So plug in 1 for y and negative 3 for x. So 4 times 1 minus 2 times negative 3, is that less than 5? Well, we get 4 plus 6, which is 10. So is 10 less than 5? No, it's not. So that's not true. So no, 3, negative 1 is not a solution. Negative 3, 1 is not a solution. Sweet. Rolling along to, let's not use that color. There we go. So for number 3, we're trying this inequality right here. So I'm going to substitute 6 in for x and 3 in for y. And I'm wondering if it's less than negative 8. Once I simplify it, I get 18 minus 30. So we get like a negative 12 there, I think. That is negative 12 less than negative 8. And folks, this one is tricky for people. But remember, you know, if we look at a number line and we have a 10 and a 5, you all know that 5 is less than 10. The number to the left was smaller. And if we have 5 and 0, 0 is less than 5. The number to the left is smaller. And if we have negative 1, negative 1 is less than 0. Like 0 is you have no money. Negative 1 is you owe $1, which stinks. And so then if we have negative 8 right here, negative 8 is less than all of these. The number to the left is smaller. I'd rather have $0 than owe somebody $8. So negative 8 is less than 0. Similarly, as we keep going to the left and we get negative 12, negative 12 is less than negative 8. So what I was trying to say there is that this is actually true. That throws some people off. So it's true, so yes, 6, 3 is a solution. Let's try the last one. We've got, 3 times negative 4 minus 10 times 2. 10 times 2. So we get negative 12, we get negative 20, that makes negative 32. So I think we're going to have the same situation here. If I did my math right, I'm doing this mentally. Did I? Oh, shoot. See my mistake? I substituted incorrectly. It's supposed to be a negative 2 for y. So that makes a chop slash. I have plus negative 10 times negative 2 is positive 20. So I get a positive 8, and that's not true. 8 is not less than negative 8, so that's false. So this is a no. Alrighty, in a second here, we're going to move to graphing linear inequalities. And when we do that, it's going to be very similar to graphing a line. In fact, you're going to think of it as a line initially, and then you are going to think about whether or not things need to be, the line needs to be shaded or solid. And then you also need to think about which side of the line you need to shade. So let's try that. So I'm going to think of this inequality as x equals 1. Now if it's x equals 1, think of an equation also as a rule. It's telling you for given x's what y need to be. Now this equation is funny because the rule is that x equals 1. So no matter what, x equals 1. They don't even talk about y. Y can be anything, any number. So I just guessed a few. Or not guessed, I just chose a few. So when you start plotting these points on this line, you get 1, 0, 1, 3, and 1, 4. Look at the line. It makes a vertical line. When you have x equals, it's a vertical line with an undefined slope. That's what happens when you have x equals some number. So then, this says x is greater than or equal to 1. I'm going to do the old test point, the old TP, and I'm going to test point 0, 0, which is right here. I want to know if this is a solution. So I plug 0 in for x and 0 in for y, just like what we were doing up top and checking for values if they're solutions or not. What's funny about this equation is there's no place to shove a y. So that's fine. I don't have to worry about it. It's less work. I just have to shove a 0 in for x. So I get 0 is greater than or equal to 1. And I check if that's a solution. No, that's false. So it's not a solution. So this red dot is not a solution. The deal is you could keep checking all of the points over here, and I promise you all of the points on this side of the line, as long as you graph your line in the correct spot, all of these will also be false. So what about the other side of the line? Well, if this point is false, this side of the line is all true. So there's our graph. Let's do y is greater than or equal to 5. We'll think of that as the equation y equals 5. So our rule, let me change colors since we are starting a new one. Think of it as y equals 5. That is a rule, and the rule is saying that no matter what x is, y is 5. No matter what x is. So 0, 5 is right here, 1, 5 is right there, 3, 5 is right there. See what kind of line we have? Yes. Oh, by the way, now when I connect the dots, and it's the same as here, I just forgot to say it. I saw it. There's an equal sign underneath here, so that means it's going to be a solid line. So when you make this straight line, go ahead and make it solid, just like you've always made lines solid as you graph them. This one doesn't have a equals underneath it, so we're actually going to make the graph with a dashed line, or try to remember to do that. So now we need to test a point. We need to know which side of that line does shade. So TP, we're going to test point 0, 0, which is right here. Hello. And then we're going to plug a 0 in for x, but there is no 0. Goodbye. Hello, goodbye, hello. See, as a Beatles song. Then we're going to plug a 0 in for y. Can I stop by in a minute? Okay. So plug a 0 in for y. And then, is that true or not? 0 is greater than negative 5. Remember, I'd rather owe someone nothing than owe someone $5 because negative is like owing. So this is true. So that means this test point is a solution. And guess what? So is everything on that side of the line. When you get a true statement, you shade towards the line. Alrighty, last one on this video. Then you have to click on the other video that I posted here to do the last 6. So think of this as an equation. Now this one is in slope-intercept form, so I'm not going to actually make a table. You could, but it's quicker just to plot your y-intercept at -1 and your slope of 2. So up 2, your slope is 2, so we're going up 2, right 1. 2, right 1, 2, right 1, 2, right 1. But now when I connect these dots, I need to make them with a dashed line. If you forget, arrow to the line and say, oops, Mr. P, I'm sorry, I'm so sorry. I meant to dash that. You don't have to throw in the extra stuff. Just tell me that you mean it to be dashed. Sometimes if you use a pen or you use a dark pencil, you can't, it's hard to change or erase. So, you know what? 0, 0 is not on that line, so I can use it. Now, if it were on the line, I would just use any other point that's not on the line and write it down, or at which point I'm checking its coordinates and where it is. So as I test 0, 0 here, 0 goes in for y. That's 2 times 0 is 0, so I really just end up with -1 on the right. Is that true? No, 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 no. Pac-Man's not eating the bigger number, it's eating the smaller number, so that's false. It's not true. It's wrong. This test point is not a solution then, nor is anything on its side, so I shade on the other side of the line. Pretty.